Hello there, listeners, and welcome to this episode of Hacker Talk, the podcast by hackers for hackers. My name is Philip, and I will be your host during today's episode. With me today is someone that has a blog that I've been following up a bit on, called tryingtobeawesome.com. He's a longtime Linux user, developer, entrepreneur, founder of effective.af, Cypherpunk philosopher, privacy advocate, hacker. The list goes on and on. It's a pleasure to have him on the show. Welcome to Hacker Talk, Steve Phillips. How are you today?
I'm great. Great to be with you. Thank you, Philip. Thanks for inviting me.
So you're involved in so much stuff, but what road led you here, and why technology?
Yeah, it's a good question. So, I've been a computer geek for quite a long time now. I started using Linux in 2001 and was doing other geeky stuff for that a little bit. Technology is such a powerful lever, right? There's a lot of kind of anti-tech, attitude in society these days. And there definitely should be against, Facebook and Google and all the spying and whatnot. But, a key thing that separates Homo sapiens from other species is inventing and using tools. And, that's basically what technology is. And so, I don't know, I just was interested in computers from a young age, and it's very empowering to be able to, write code and deploy it out to the world and be leveraging automation. And it's very exciting. And then especially as, INTJ, geeky personality, be able to sit in front of my computer and, master something and do cool things and not need to, need like a huge group of people to get something done is really empowering.
Absolutely. Was there anything like a light bulb moment where you realized like, wow, this is really cool and this is really something I want to allocate more time for?
Yeah, it's a great question. There was a key moment was definitely in 2012. There's this video that Julian Assange put out with 3 other cypherpunks, and they basically made a very compelling case that the future of the internet will determine the future of humanity, because everyone's life is flowing over the internet these days. And so that makes us all very vulnerable to, say, mass surveillance, and hacking and things like that. And so that specific video actually convinced me that I should dedicate myself in a major way to blanketing the world with end-to-end encryption, protecting people's privacy, so that, I understood immediately that if you look at things from the perspective of, say, the NSA, and of course, this is even before the Snowden revelations, right? Like a year and a half before. And even though we didn't know that the NSA was looking at everything all of the time, just understanding that the potential was there for something like that, and that even doing, 5% of what the NSA is doing is still super dangerous. And so, yeah, again, there's that appeal of like, okay, it's me sitting in front of my computer, write some code, deploy it, millions of people can be protected, or billions potentially, now that there's like 4 billion people online. And so that was very compelling. Like at the time, like I was, doing some programming, had mostly been doing a ton of philosophy. I invented a new philosophical methodology that has you write software in order to like encode philosophical arguments and things like that. And so, I was focusing on trying to revolutionize that, trying to make it possible for philosophy to make progress by having well-defined terminology written in software. And then the idea is you could kind of compute philosophical facts, at least do things like make sure that your belief system is logically consistent, which is not something we have the tools to do right now. And so I thought philosophy should go in that direction instead of trying to answer things that can't be answered. And so I did that. So I had this kind of transition period of, always doing computer stuff, but was kind of winding down some of the philosophy, and then realized that being a cypherpunk was the track for me.
How do you kind of engineer that?
Engineer which part?
Putting the philosophy part into.
Yeah, no, it's a good question. You could see specific code examples at executablephilosophy.com if you if listeners would like, but yeah, I mean, it's not necessarily super, it wasn't immediately obvious how you could do that, but to give you a specific example, like if you wanted to kind of, if you wanted to calculate like what a certain philosophical theory says in a certain situation, like whether or not a certain action is ethical or is say is moral. I made it so you have like you have these different classes, like Python classes.
Okay.
Python's the only language I knew at the time, and so I said, okay, even though in theory Haskell or something more, immutable, let's say, or functional or whatever, maybe that would be better. I was like, I think Haskell's too complicated for philosophers that need to do something simple, and like to get them to learn how to code is like a huge ask. I mean, they're used to formal logic, and complex things like that. But anyway, but to give you a concrete example, like you basically create a Python class that like inherits from this kind of special kind of exfil.theory like kind of base class, so that like all of the philosophical theories have like certain like fundamental things in common, that like certain like attributes and methods, and basically you define an is moral method on your class, and so you can create instances of these classes and say, okay, I want to detect the fact of the matter as to what a certain ethical theory says in a certain situation, because there's this problem that keeps happening in in the field where someone will say, oh, you have all these examples where my theory is wrong, but you misunderstood my theory. My theory doesn't actually say what you say it does. You misinterpreted it. But we shouldn't have that problem, right? I should be able to take your theory, like run my input against it and objectively calculate the output. But you can't do that in philosophy right now. You've never been able to do that after thousands of years. And so trying to solve that problem, among others.
Yeah, that's very interesting. It reminds me, I had a discussion with a friend who's like convinced that words are not objective, because exactly like you said, everyone has different definitions of that. So they automatically becomes subjective.
Yep, yeah, exactly. And so if everyone's forced to precisely define, like you could have different people's definitions of the same term or whatever, which is fine, right? You can have different things with the same name in different files, and so then at least we could see, okay, well, at first blush, your definition seems more reasonable than mine, but wait a second, but it turns out if you do all these crazy calculations that this other thing that you and I really agree is definitely true, maybe that's subtly logically inconsistent with like your other theory of whatever, and therefore overall it's better to choose a certain other definition. So I thought at least logical inconsistency is objective, and then if you can have objective definitions, then maybe progress can be made. Now, people still argue over what the best definitions are. That doesn't solve that problem, but I figure at least something resembling progress could be made, and it doesn't seem like that's really happening in the field. Philosophy has, Western philosophy has turned into the people trying to answer questions that don't have answers, and that's a huge waste of like some very, very smart people. But anyway, yeah, I've been doing Cypherpunk stuff since then for the most part.
Awesome. You mentioned there, you've been programming Python, but how was your programming journey?
Yeah, that's a good question. Started off bunch of Python, bunch of Django web dev. I was reading a lot of Paul Graham's essays in 2005, like 2006, right in the middle of college for me.
And so the lisp, yeah.
And then this is, around the time he started Y Combinator, and he's basically writing stuff where he's like, it shouldn't be these like business guys that think they have good ideas, but actually don't, and who can't build the product. Like they shouldn't be in charge of everything. It should be like technical people who can have like deeper insights by understanding the technology, if they're also good at coming up with, more general ideas and recognizing problems in the world. And then combining that with being able to build the product, which you really need on your core team if you don't have any funding yet and things like that. And so that's who should be in charge. And I was like, wow, that sounds really appealing. Like, I'm going to be graduating college in a couple years. I don't want to go work for someone else who's like not going to, recognize a good idea. I don't want to be like under, someone else. I was also reading a lot of Chomsky, and I'm like, okay, I'm not going to be a wage slave and be, just be a cog in the corporate machine. That sounds very unappealing. I want to be free. And so the idea of combining programming with entrepreneurship, that seemed like a really powerful combination. And so the initial plan was like, okay, I don't know if I'll ever really be a good programmer, but, I want to revolutionize philosophy. And so, and fund other revolutionary projects that are trying to, create a paradigm shift in other fields that really need it, like psychology and economics, for example, like those fields basically don't work. None of the predictions are really there, that no one has a clear theory of mind. So anyway, there's these things you can get like a PhD in that I don't know, or that you can win a Nobel Prize in, even though, that they can't predict things accurately. But anyway, but I'm like, I want to fund other, my philosophical work and like other interesting projects. And so I know I'll learn enough programming and use my kind of general systems thinking ability for entrepreneurial means, build maybe like the first version or first and second version of some software product, and team up with people who like actually know something about startups, unlike me, at the time. And then, build something cool and maybe sell it. And then, okay, then I would have those funds that I could use to make the world better in various ways. But with a particular focus on revolutionizing fields of knowledge and maybe industries that really need it. And so that's why I started with like Django web dev, and then, have gotten, I've been programming for 14 years, and then after some of the Django web dev stuff, I realized like, okay, the world, like around 2010, I'm like, okay, the world is going multi-core. Python very inefficiently uses one core. I want to efficiently use all the cores. Wouldn't it be ridiculous to have, 64 cores and you're using one of them and it's like 24 times slower than C. I'm like, okay, that's like not that cool. And there's things you can do to run a different instance of your app on each CPU core on a server and stuff like that. But that seemed like a hack.
And async.
What's that?
And
Oh yeah. Yeah, I want it to be more efficient. But anyway, so then I started learning some Clojure, which is like the most complicated programming language. And so I dove into that.
Why did you pick Clojure?
Partially because of Paul Graham's essays making Lisp sound like the greatest thing ever. And also because Rich Hickey, clearly a brilliant guy, and made a compelling case for it and made a practical Lisp, right? I actually tried to do, a little bit of like Common Lisp in like 2006 or so. And I'm like, okay, I'll just do something simple. I'm going to like scrape a web page and try to grab some information off of there. And they're like, yeah, there's not like a standard way to like do HTTP calls in Common Lisp. And I was like, are you kidding me? This is ridiculous. Like everything else has mature libraries for these things. So I'm like, okay, I didn't realize some of this was so underdeveloped or so optimized for like the previous era and the era before that of computing. And so I ended up doing, Python for a while, but then Lisp, like, okay, like the idea that you can use all of the libraries from Java and all of the Clojure specific libraries, and it'll be fast, unlike Python for the most part, especially then, that sounded really appealing. And then kind of the mathematical beauty of stuff. Anyway, there's a lot of allure around that. At this point, I'm convinced that like static typing is actually really important and will save your ass, and like generally needs to be there. And so anyway, so I spent like 6 months or 10 months or something going deep into Clojure and trying to really understand it. Again, after I've been programming for like 2 years, I jumped into, too deep, but it was very mind expanding. And so, and then in November of 2010, Go turned 1 year old, and it made it to like the front page of Hacker News, and I read it, and I was like, I was hooked immediately. I was like, this is very simple. Within 1 hour of reading Go code, I wrote my first concurrent program, whereas I spent like months trying to just comprehend what was going on with Clojure. And so since then, I've written a lot of like highly concurrent Go code, especially on the server. Sometimes
how was Golang in the beginning? Was it very buggy or was it painless?
It was pretty painless. It was not buggy at all. Go's never been buggy. I know inside of Google, it started in 2007. They worked on it for 2 full years and then publicly released it in November of 2009. And then November of 2010, like I said, it turned 1, and that's when it got onto my radar. But Go was great. Before Go 1.0, like there was like they call it like R58, R59, like for revision. And Go was originally using Subversion rather than Git, I believe. And so anyway, so Go goes back a little ways. But Go was great from the beginning. There's been significant changes. They made a bunch of breaking changes before Go 1.0, and I was expected that was fine. There was a tool called Go Fix, and you could run Go Fix against your code, and it would rewrite the code that you had written that was like using the old APIs and rewrite them for the new one. And so like
that's so useful. I've spent many hours in the last 3 months I've been rewriting this Rust library and new APIs. Such a pain in the ass. Such a pain.
Yeah, exactly. And so I mean that's now I realize that's affected my thinking significantly. And like I think a lot about like, okay, software's actually broken in so many ways. It takes forever to get something simple to, relatively like conceptually simple to work. You go to upgrade libraries and everything's breaking all the time, especially in the JavaScript ecosystem, which unfortunately I'm very much in. It's if you want to build an app once and have it run everywhere, unfortunately JavaScript is like the most practical way to do that.
Web has the biggest user base right now.
Yeah. And so, so anyway, like, as far as like where some programming stuff should go, like we absolutely, like every time you ship like a breaking change to a library, it should come with it bundled code that will rewrite the code of whoever's using the library to change it from using the old version to the new version. Like that should be totally standard. No one's doing that. It's ridiculous.
It's such a mind chaser because I spent countless hours like debugging, rewriting software, and then this library calls this library, but it's not compatible with this version of this word. Yeah,
exactly. So that's
hair ripping. Yeah,
exactly. And it's like if you think about some of this from like an information theory perspective, it's like all the information is already in the code base to make the change. And like if you think of the information like in Git, where it's like here's the previous version of this library, here's the next version and like the next commit, here's the changes that were made to the tests that were calling things in the old way, and here's the specific changes that were made to call it in the new way. It's like the information is there to infer what the code should look like that's calling that library that was just broken. And so there's all this ridiculousness around, if you just use semantic versioning, then you're communicating what's going on. People break things without realizing it. But like Semver, again, the information is in the code. So to try to socially communicate, hey man, watch out for like this breaking change because I went from V3 to V4, the major version incremented. Therefore, I let myself off the hook. I don't have to, I can just leave my own users in the dust. They don't get any updates. It's so wrong. And so I've tried to think about analogy, like physical analogies to make it clear just how absurd this is. And I keep thinking that like, what if like a new version of like the $1 bill and the $5 bill and the $10 bill came out like every year? And then, so you go to one store and you can use like some versions of a $1 bill that are like compatible with their cash registers and some versions of the 5. And
use some ATMs for some bills and
yeah, exactly. And so you go to the nearby, you get stuff you can only buy stuff in certain stores. It's like that. That's how the world would be if software developers had designed it. Apparently, like that's how bad things are. So. But what's the solution? I'm like, well, what if you had a machine that could take like any version of any $1 or $5 or $10 or $20 bill and like convert it to the latest version. Then everyone just accepts the latest version of everything. All the old stuff gets upgraded and everything works together. And that's exactly what we should do with software.
Absolutely. I couldn't agree more.
But I mentioned that in the context of some Go stuff. So anyway, I did Django, then Go, then a bunch of JavaScript, a bunch of React, and then some Svelte the last couple of years, which is very good. I keep thinking like, okay, if you did this with just like one, so you did this like with one programming language, or like maybe there's a particular library that is very popular where they keep breaking backward compatibility. I mean, it's just a demo. Like, someone needs to like do this rewriting thing, and then, like literally submit like, 500,000 PRs in one day and just be like, hey, this upgrades your code to the latest version of React or the latest version of, Kubernetes. There's things that are huge and complicated and, and not exactly backward compatible. And so it would save the world like so many millions of hours, literally. If you think of 40 million developers, how many people per year spend how much time? It's like billions of dollars.
Yeah. It is a lot of money. Have you seen this been implemented in other languages rather than Go? Or
no, and what Go did was in a very limited way. But yeah, and that was just like a before Go 1.0 thing. Like there hasn't been,
no progress in it.
Right. I think the conception of Go Fix was just, okay, for like the Go standard library, like before version 1.0, we need to have an upgrade path. But again, that's how everything should work all the time, not just Go before version 1.
They should save so much energy and so much time, just like you said.
Yeah. And then from a security standpoint, if you're like, oh, I can't upgrade this library, even though there's some like, moderate level, medium level, vulnerabilities. Okay, it's like a denial of service thing. Maybe it's not like an RCE. I don't want to break my whole code base. And so I'll just stay where I'm at. Like, I'm sure many other people have thought the same thing many times. And, but if you didn't risk breaking everything by upgrading, then things would be more secure.
Absolutely. If you didn't have a chance to brick your device or.
Yeah. And then, and then you just like benefit from the security updates that have, generally have nothing to do with breaking backward compatibility. And, we need things to be safe. So that's totally the right trade-off. But people can't make that choice right now of like, yeah, I'll use the latest version and automatically get all these security benefits. If they have to worry about breaking compatibility.
Yeah, there's a huge gap there,
for sure. But anyway, but Django, then Go, then a bunch of JavaScript. Most of the things I built in the last few years are encrypted end to end. So like, there's something I built called Leap Chat that is like end-to-end encrypted chat in the browser, and so. That works a lot better than other things for certain threat models. For other threat models, you need to use a native app, and that's important. But when you work with like, many activists in many countries, and they don't want to like expose their phone number with Signal, and some people worry that anything built in the US was like funded by the CIA and was backdoored and stuff. And so they don't want to install certain things on their device. And so if they can use something that's kind of trapped in the browser, if they can use over Tor browser, for example, then use it anonymously, really conveniently, then that can work. So yeah, so that, I don't know. I don't know how many messages have been sent through Leap Chat because they're like ephemeral, and you can like delete them earlier than they expire. But I think there's like something like 20,000 chat sessions that have kind of chat rooms that have been created. But anyway, so that was a React code base built with some other some great people, and then but I've been doing a bunch of Svelte the last couple of years for like kind of the new code base for some end-to-end encrypted stuff. But that's been the trajectory and kind of sequence in terms of programming languages. I should also add that I'm a huge fan of the design of this language called V. V, like the guy Alex Medvednikov basically took the design of Go and fixed like all 10 things wrong with it, in my view, to make something that's really brilliantly done. Now,
and it has a much smaller runtime, right?
It does. Like so V code compiles down to C, and then you compile that C code, that hopefully safe subset of C, with a normal C compiler. So the V to C translation is super fast, and then all the C code is in one file, and so you don't have some of the issues with compile time that you have when you have like a huge tree of things, and some like libraries may get compiled multiple times. I don't know, Rob Pike says that like one reason why huge C++ code bases in Google took like 44 minutes to compile, even like on a distributed cluster. Like this, and they're saying that was part of the origin story of Go. They're like, we're sitting in Google, we're surrounded by infinite compute. It takes 44 minutes to do a new build, and we're like, oh, okay, there's something wrong here. Like we should be able to compile things exponentially faster. And so Go compiles super fast, V compiles super fast. They've made some different trade-offs in the internals. So like Go is totally fine with like having a bigger runtime that's scheduling Go routines and doing garbage
green threading, right?
Yeah, exactly. They call them green threads or coroutines or Go routines, or similar kind of similar sorts of things. But yeah, super efficient concurrency, like 2 KB of overhead to spawn a new Go routine. Whereas, it would be like megs of overhead, to spawn like a whole new OS thread. But Go routines are multiplexed onto real OS threads. So you can have, you could be downloading 100 things at once, and the Go runtime will kind of schedule like usage of the CPU for those, say, like 100 Go routines that are doing different things, and they kind of take turns on that CPU core. But if they need to use multiple cores, then the Go runtime will kind of spread those Go routines out among multiple cores. So the idea is you don't have to worry about that. Whereas in like C or C++ or something, if you're daring to write concurrent code, you have to worry a lot more about those details.
Do you feel like languages such as V and languages that have a small runtime become more and more popular as more embedded devices and Internet of Things devices become?
Right, become popular. That's a good question. I actually think the opposite may be true in the sense that, like, as the definition of embedded gets like beefier and beefier, and now like an IoT device has like a gig of RAM, it's not as important to like have the runtime and the size of the binary be super tiny.
Oh.
But the idea of V is like, well, like what if you could like program in Go, but or a program in something that feels like Go, but is better, like the types have methods on them, which is really convenient. Like Go doesn't do that. You can add methods to your own custom types, but like strings, don't have a split method and all the
okay.
Trim left, trim right, all of that stuff. But so V says, and also there's a language called Go Plus that actually kind of forked Go and like added some syntactic sugar on top. Like they've done a good job of that design, where you do have methods and some more conveniences and less boilerplate code that you're writing for error handling, but it's like semantically equivalent. So you're not like resorting back to exceptions and having things kind of exploding and, oh, I forgot to handle that exception and the whole program died. That's a common thing, right? For like scripting languages in particular. And so it's good to have things be safe. But to have them be like safe and convenient for the programmer and to have the code run everywhere, V is about the only language that is doing that in my view. Now that's again, a huge fan of the design of the language. I don't know whether the implementation is great. I mean, it was like awesome at the, they were making amazing progress at the beginning, and then of course tried to do these way more technically complex things with, handling generics and all the corner cases of that and whatnot. And so, there's been some valid criticisms of some of the implementation of V, but things are getting better, and I'm very impressed with the design.
Yeah, it's interesting to watch. I went through like some Hello World tutorials and tried to compile it, and pretty fast. Nice to see.
Totally. Yep. Yeah. And like you said, that like the resulting binary is very small, and then there's even like a new flag where you can, it's not enabled by default because it's not mature enough yet, but there's ways to do the equivalent of kind of tree shaking, and like where it does like this extra check to be like, oh, okay, this part of this piece of code isn't actually used for this program because it doesn't, use that part of the, quote unquote runtime. I mean, it's debatable what a runtime even quite is, but V tries to be like super minimal and like almost no runtime, which makes it harder to do like efficient concurrency. And right now it doesn't do efficient concurrency. It just spawns a whole OS thread when you launch what is syntactically looking like a Go routine, and even uses the Go keyword and, borrows that from Go, but the binaries are even about to be significantly smaller by doing tree shaking sorts of things.
So you mentioned there that you work on LeapChat and encrypted chat platforms. Isn't doing that is you have a lot of threat models, like you said, and you have a lot of attack vectors. What was going through your head as you were like designing the implementation and the protocol?
Yeah, that's a great question. So, like of LeapChat in particular?
Or in general?
Right.
How does your process work?
Yeah, it's a good question. Threat modeling is important. It's important to tell people that anyone who's trying to say like, okay, we're using, military grade encryption, obviously that's one of those, snake oil salesman things, so, everyone's using, like the military is using the same thing everyone else is using, but
AES, the Riandel,
for sure. But anyway, using, using libsodium or, NaCl, like, obviously avoiding avoiding rolling your own cryptography. That's super important. But I mean, to talk about, say LeapChat, for example, something that's really important to understand from a combined kind of security plus usability perspective, is that, it's easy to think that like, okay, here's here's a few secure things that users could do, and they just shouldn't do things that are not more secure than that. And so even if it's less convenient, even if they have to learn a bunch of things, users ought to, jump through those hoops so that things are really secure. But if you're trying to like protect real users and not just build a secure artifact that may or may not be impossible to use or too inconvenient, it's really important to understand, how users think about things. And so what they're actually going to do is like they're going to use, they're not doing security first and then just dealing with like arbitrary levels of inconvenience or difficulty. It's like they're going to use the most secure option available that is sufficiently usable. And that like if they try to use it, it will it will actually work, and they can like get onboarded in like a reasonable period of time. And so, so if you think that through, and then you look at what, say, like WhatsApp and a couple things have done where they say, yes, we have, and I think, and some other messaging apps, they'll say, yes, we do have a web app as an option. Yes, it's true that, you're trusting the server more than one would like. But my philosophy is I'm employing these days is like, okay, if people can like quickly use something and try it out, I send you a link, an invite link, you click on it, boom, you're in, and like, okay, this is good. And then, if you install a native app after that, then in the end, we're actually securing a much larger number of people. Like it is very surprising how
you need to make it user friendly.
Exactly. So it's actually quite surprising how difficult it is to convince a normal user to like install a new app and to create an account and to write down like a backup key phrase thing or your passphrase, which Keybase does, for example. And like we put all of these hurdles in front, that optimize security at the expense of usability. And again, that ends up securing fewer people because so many people drop off and don't end up using things, and then you never get critical mass with the thing that you're building, and so you're not protecting people. And so it's a controversial view because again, you're trusting the server more than you'd like, and part of the point of end-to-end encryption is you shouldn't have to trust the server. But I will say there's actually some really interesting things that are being done regarding web apps that I'm looking to integrate, where you don't trust the server so much, which sounds like impossible, right? So okay, you go to a website, isn't your browser guaranteed to be blindly trusting the HTML, CSS, and JavaScript that it gets from the server? And there's somebody who came to one of my privacy hackathons that I ran for a while in San Francisco at Noisebridge, and he showed me this technique that actually Proton Mail got wind of a couple years later, and so he did work for Proton Mail doing the following. And so here's the idea: modern browsers have something called service workers, and a service worker it's almost like cross between a normal web app and a browser extension, where it's a blob of JavaScript that is installed into the browser. And even when you're not viewing that web page, it can be doing things in the background. And so he came up with this amazing technique where when you go as background, I should say that when you visit a site where you already have a service worker installed, the browser will default to using the already installed JavaScript. Like for efficiency reasons, it doesn't fetch, even though you're like opening a new browser tab and you're going to that URL, it will actually fetch the JavaScript that is local. And so
it will cache all the JavaScript from everywhere.
All the service workers specifically. It's like like a website needs to say, hey, here's the service worker specific JavaScript. But yes, if it's a service worker that's being cached by the browser, like you say. But the idea is you can have that service worker like talk to the server, download like the next version, like the newer version of itself, and like hash that, and then do another call to like GitHub and see if it's the same code that is like publicly deployed to GitHub as is on the server. And so the idea is that the attacker, the idea is that like if there's a discrepancy and it's like, okay, these are different versions, so maybe someone just hacked into the server and is about to give malicious JavaScript to the user. The idea is the service worker that you're already trusting, it's already in the browser. So this turns into almost like a trust on first use kind of like tofu model. Even though it's a web app, the idea is it could notify you and say, hey, like this is, and potentially take other actions, right? Like, hey, the next version appears not to be trusted. So you can imagine, if it's like an emergency scenario, or if it's like a super sensitive use case, or maybe users can opt into saying like, hey, I've already backed up my like account key elsewhere. And so if there's like a malicious JavaScript blob coming from the server.
Oh, like, that's not properly signed or okay.
Yeah. Or it's at least not, not the same content as what's publicly on GitHub. And therefore it's like unlikely that, an attacker would, at about the same time, hack into the server, replace it with JavaScript, somehow get access to the relevant people's GitHub account, and then like add those commits. And then, oh, by the way, if that's public, that's actually really risky for the attacker to to expose, what they're doing. So anyway, so it gets you much closer to the model of what we think of with native apps, right? Where it's like, only if the signature checks out does, will the app like, ideally, grab the new native app like from an app store or something like that. And so it's pretty interesting what is possible with modern web apps now.
And something that's becoming more and more popular is WebAssembly.
Yeah. So I don't know how much it can solve some of some of those other pieces with some of the threat model, but I'm a huge fan of WebAssembly, and I'll tell you why. Like right
Why?
now, people think of WebAssembly as this kind of toy that only runs in the browser and that you sometimes use to like speed up your numerical calculations you do in JavaScript. But that is like the lamest and simplest and like first use case of WebAssembly. Okay, here's what WebAssembly actually is. Not just the first thing it was used for, but what it is and what it can be used for and will be used for. WebAssembly gives us the opportunity to, not all these features are there yet, but here's where things are going very explicitly. With WebAssembly, you will be able to program in any programming language you want, compile your app to a WebAssembly module, and have that one version of your app run absolutely everywhere. Like in every browser, yes, but on every server, every smartphone, every operating system, every platform, right? And then furthermore, you'll be able to import libraries written in other programming languages because those libraries will be compiled to WebAssembly as well. And so you'll have WebAssembly importing and using WebAssembly rather than, Python trying to import Go. And, people have hacks to try to, pretend that works. And there's all this nasty bridge code and there's all these penalties when you go from, when you cross the bridge. And so people can't just like write a for loop that isn't like unperformant. They have to like send the array across the bridge to like the other programming language, like if you have Python wrapping, C code, for example, and then like do the for loop in C and collect your result and then pass the resulting array back. Like you can't even program in a normal style. Plus security wise is the big thing. So WebAssembly runs in a super, super efficient sandbox. So people will understand that WebAssembly is almost like the ultimate kind of container technology. So it's like we had VMs with like hundreds of megs of overhead, and then you have Docker, which will be surpassed by Podman. That is very much a prediction. You will see Docker die and Podman replace it in the next few years as like the dominant solution. But VMs, and then Docker with like however many megabytes of overhead, but you still kind of have a whole OS in there usually.
It shares the hypervisor and
Yeah, totally. And so you've got Docker itself, there's still quite a bit going on there, and but it's still way more efficient than VMs, and they start up, in like 100 milliseconds or something like to spin up a Docker container. But with WebAssembly, we're talking about like kilobytes of overhead for the sandboxing, and it's like way better sandboxing than what you get with Docker. Like, I mean, the creator of Docker a few years ago was like, we're trying to get to a world where we have containers that actually contain, right now you have isolation. And so, to a certain extent, where if you have like trusted code running in different, containers on one machine, then like that works great, right? And each service can have its own kind of, Postgres instance if you want to keep those separate and you're not having everything share what's on the host. And then, sometimes, whatever you like one of the services needs to upgrade Postgres, but the other can't have it be upgraded. And so it's bad that they're sharing the same database on the host. And so anyway, there's all these things where it's great to separate things out into different containers or pods. But anyway,
it's not meant for security. I know I had a talk with a person that worked for Docker, and he literally tells me that there's so many privilege escalation vulnerability just comes out, and we don't have security. Get over it. He basically told me. Yeah, it's for containerizing. It's not how you do security. That's someone else's job.
Yeah, totally. Yeah. And and again, it's like a trusted versus untrusted code kind of thing. It's like, it would be great if, when someone hacks into one of your microservices, that the other microservices running on the same VM, or the same bare metal machine, it would be great if you had better guarantees that they couldn't kind of take everything over, and so so like I personally run Cube's OS as my main laptop, and like different apps are running in different VMs, and it's surprisingly usable, but like because it uses Zen and not like VirtualBox, when I think VirtualBox, I think, okay, this is so much slower. You couldn't really realistically use this day to day as like your main OS, but Cubes is usable. But I mentioned Cubes because you do get super good isolation, but at the cost of so much inefficiency. Like, it's like 500. Yeah, exactly. It's like 500 megs of overhead for like each app that I'm running, which is insane. But with WebAssembly, we're moving toward a world where you could take those same pieces of software, compile them to WebAssembly, run them in this like super efficient sandboxed way. And so you could just have like a normal OS and like WASM time or WASMer or some like WebAssembly runtime like that, and then have all these apps that really are isolated very well from each other, like as well as a VM, but with kilobytes instead of hundreds of megabytes of overhead.
And they're all running using the nanopros model as well. So they're all running in their own small memory space, and they don't have access to syscalls or shared resources or dbus or maybe dbus, but
exactly. Like they only have access to exactly what you give them access to. And so you can say, I want my calculator app, like right now, okay, if you're on Windows, you run your calculator app, it's running as your user. And so it's inheriting all of the privileges, right, of your user. And so, here's a question. Should your calculator app or your spreadsheet app have sufficient permissions to nuke your home directory?
Yeah, to read your password files.
Exactly. It doesn't need to do any of that, but it's more convenient. And there's like 40-year-old conceptions of how like file system and user permissions should work that we've all inherited. And so, when people are debating whatever, Linux versus Mac OS or whatever, and or Windows, and okay,
the BSDs and
it's like, okay, I have my favorites too, and yay open source, but like these are still not fundamentally different beasts in terms of how they think about, again, permissions and security, and things are not that isolated. And, iOS is a bit different, and they try to do some more serious sandboxing, I guess. But, but with WebAssembly, it's like, it's a whole new ball game. And again, whatever programming language you want, super secure. I mean, you mentioned the nano process model. With WebAssembly, you're not even fully trusting the libraries that you're using in your app, like the library that okay. So let's say you write let's say it's whatever, 6 years in the future from now, it's the year 2028. You're programming in whatever, Go, Rust, Python. Hopefully we've left JavaScript behind. Probably not. There's millions of people using it, but whatever. Even that, right? You compile your JavaScript code to WebAssembly, but but say you're building an open source, Dropbox clone, and so it actually does need to have access. Your app does need to have access to a bunch of disk, most of the folders, not all the folders, but most of the folders, and it needs access to the network. And so you might think, is WebAssembly going to help, with something that actually needs a lot of permissions? And so you need to give it, you need to put a lot of things in that sandbox. The WebAssembly code does need to have references to all sorts of things. will it help me then? And to be clear, even if it didn't help, like WebAssembly would be so good for all these other things. It only needs to access disk, or only needs to access the network, or many things need to access one folder or one file, like its own config file or something, and then be able to talk to the network. But again, doesn't, calculator app may need to look up exchange rates when, doing currency conversions, but it doesn't need to read your, have permissions to your .ssh, or .gpg, or GNU PG directories.
Yeah, no sensitive stuff.
Right, exactly. But even in the case of, say, like an open source Dropbox clone that does need tons of permissions, you could have it where it's basically your code that you compiled to WebAssembly that you wrote, but not your libraries. Your code basically gets references to to disk and to the network, but you can still limit the permissions of your own libraries. And so you can have something that does string manipulation, and maybe you don't realize that the latest version of that library is actually malicious and is mining Bitcoins or stealing your private keys and sending them to who knows where. Like even the library in your app would have limited permissions. And there's actually examples where this has happened. Like someone built an Electron app, and you used a bunch of libraries, of course, which should be fine, right? It should be safe to use to use libraries. But there's a library that was doing some limited thing, but it inherited the permissions of the entire Electron app, that entire process, because that's how permissions work right now. That's how the security model works on all the major operating systems. And so they I think stole people's Bitcoins for like 90 days before people realized, oh wait, our library is malicious, and then they released a new version of the Electron app.
I saw that statement on their website.
Yeah,
and I was so happy that I didn't update to that version.
Yeah, it's crazy. So we should be living in a world where it's not where everything has minimum permissions that it needs to do its job, and that will solve quite a bit. Oh, by the way, compiling the world C and C++ code to WebAssembly will make it will make it impossible for certain kinds of vulnerabilities to exist. I think
I was thinking about that. Like, what if someone has a lot of like weak string copies, or has all the classical bugs from C?
Yep. Like, I believe that that there's like bounds checking in WebAssembly. So anyways, there's various, I forget exactly the, I don't want to overstate the range of things that are kind of automatically solved, but it's quite a few things that are not feasible, because, I'm talking about WebAssembly and, the way that I think of it, which is this kind of like, like cross language, almost like an intermediate, representation or something, but it's actually technically a programming language in and of itself. And so, so just like any other language, you can just say, there is bounds checking, and so, like buffer overflow, buffer overflows can just be like structurally impossible. But, obviously, if you have type safety and memory safety, then there's certain classes of bugs that like cannot occur. And of course, there could be bugs with, with those checks or something like that. So just like, but anyway, nothing is perfect, but to try to make things as secure as possible, and to have bounds checking instead of not. I mean, yeah, there's entire categories of bugs that are impossible in WebAssembly, just like they're impossible in, just like you can't have buffer overflows in JavaScript or whatever.
That's a good answer.
I'd also like to add briefly that ridiculously, despite all these advantages and upcoming advantages of WebAssembly, the main pushback I hear is from C and C++ programmers and people working on operating systems that are like, wait a second, like my C and C++ code is going to run 35% slower once it's compiled to WebAssembly. That's not acceptable. It's like, okay, so why are there millions and, so I guess like programming in JavaScript could never take off, right? Because it's 200% slower than C, but 35% slower, that can't work. So there's people who care so much about and hyper optimize for efficiency. And so they think, oh yeah, it's just a total deal breaker, to make your C and C++ code slower when you compile to WebAssembly. But it's making all the other languages faster, and it's making the C and C++ dramatically more secure. Like, this is such a big win. It's very exciting.
It is. I think more people should adopt WebAssembly, and I want to see it more in use. Do you deal with WebAssembly in your day-to-day life? And what applications of WebAssembly have you used?
That's a great question. So, I mean, let's first say like some fairly prominent use case, like not just use cases, but like, not just kind of potential use cases, but like real world success stories already. Like it's more popular right now than some people realize. So for example, there's all these kind of, so for example, if you look at what Shopify recently announced, like Shopify had this interesting problem where they're like, okay, we want to support all these kind of third parties that are making these kind of Shopify plugins, but a lot of those plugins rely on infrastructure that's built by the same people who wrote those plugins. And sometimes we get huge spikes, in traffic or different, Shopify web stores or whatever, e-commerce sites that integrate with Shopify, they'll get a big spike in traffic, and then all that traffic is going to some of these plugins. And so, the plugins get overwhelmed with traffic, and we want like Shopify to be really reliable. And so how do we solve this problem? They used WebAssembly in a really interesting way. They said, okay, we're going to host the backend of a lot of these plugins instead of their creators hosting them. But of course, that creates the problem of like, how do we know that this code isn't malware? Shopify's like, we're going to run arbitrary code on our servers. That's inherently dangerous to do. Well, they compiled that code to WebAssembly, and so they didn't have to trust it because it was in a little sandbox. And WebAssembly modules spin up in like 50 microseconds, which is like, many times faster than even a Docker container. Earlier we said, okay, 100 milliseconds, that's really fast. But yeah, so there's the Shopify success story. I mean, they spun out, I forget the exact numbers, but there were large spikes in traffic that were handled really well by these like server-side, WebAssembly modules that were compiled from people's arbitrary code. So that's really cool. Cloudflare and a couple other companies like them are doing super interesting things with WebAssembly, where
what is Cloudflare doing with it? Because I feel like Cloudflare is always doing like cool things. Have you seen their lava lamp? They have like a lava lamp wall where they generate prime numbers based on how they're moving.
Oh no, I didn't know Cloudflare did that. I had read years ago that like there was like a low cost experiment someone did with lava lamps to generate entropy or to use that as
exactly.
That's super cool.
Cloudflare did that and put it to use case or something. Yeah,
that's awesome. Yeah, no, Cloudflare does some very interesting things. People should know that Cloudflare, which operates at like a larger scale than basically anyone else, right? They have 200. What do they call them? POPs, like 200 like points of presence around the world. I don't think it's 200 full data centers, but it's like full or partial data centers or whatever. 200 locations. I mean, so anyway, they operate at like on a larger scale than basically anybody. They, by the way, don't use Kubernetes. They use HashiCorp Nomad because it's way simpler and they can like reach a super huge scale. I also predict Nomad will overtake Kubernetes. Kubernetes is way too complicated. Fortune 100 companies should be using it. I don't know why other people think they need it. But
you
anyway.
mentioned Podman should take it over.
Podman over Docker. Yeah, for sure. Docker split in two. There's people trying to figure out some kind of business model for Docker, but everyone wants that level of infrastructure to be totally open, and that makes it really hard to make a business model off of it. And every time they try to make like a closed source, kind of plug in and do the open core thing. I mean, there's so many competitors and so many people want those parts to be open source as well. So I think Docker is in trouble. They deserve credit, obviously, for kind of creating the concept of the, modern concept of a container. And, that's great. But Podman, Podman is made by Red Hat. They make tons of money off of other things. And so it doesn't matter that
enterprise licenses and yep.
Yeah, exactly. And there's like OpenShift that Red Hat makes money on. And so they need Podman for that use case for their own kind of, cloud own, PaaS, platform as a service. And so anyway, that's very stable. And the whole architecture of Docker has a single point of failure needlessly in it in the form of the Docker daemon. And, if you want to upgrade the Docker daemon, you gotta, restart, you gotta restart the daemon. That kills all your containers on your machine. And, people are used to that. So it doesn't necessarily feel like there's anything wrong. We've got, we keep lowering our standards over time and not realizing how bad certain things get. It just becomes normal. I feel like we're boiling frogs sometimes. Like we are the frogs that are slowly boiling without realizing, with all this complexity and things breaking. And it's normal. I'll just manually, fix things, or I expect things to be broken and blah blah blah. But anyway, in the case of the Docker daemon, we're used to it being there. But imagine if you had a bunch of terminals open, you've got Bash or Z Shell or whatever running. Suppose it's Bash. If whenever you upgraded Bash, imagine if all your terminal windows disappeared, you lost all that stuff. It's like that's what it would be like, but it's unnecessary, right?
Yeah.
So how does Bash actually work, right? Well, it works like basically everything other than the Docker daemon, right? Where you could have the old process, running. It's a self-contained thing. It doesn't rely on some other daemon that it's running on top of. And so that architectural decision is a mistake and totally unnecessary. And Podman doesn't make that mistake, for example. But anyway, so that's so there's technical reasons and business model kinds of reasons for why I predict that Podman will be the dominant container solution over Docker starting in a few years. But to jump back for a second, but in terms of WebAssembly, Cloudflare is doing some interesting things. So they want to make it where you build your software and then can kind of instantly deploy it to any of their 200 locations.
Thank you for listening to Hacker Talk. We will be back soon with part 2 of this conversation with Steve Phillips in a week. Until then, my name is Philip and I will see you in the future.